Alright, here in my right hand we have a clutch, which is going to spin and engage the chain. If you can see, this right here has 11 teeth on it, and it just slides right onto the shaft, and then as the shaft spins, it's going to spin those 11 teeth.
Alright, this is what Christian was showing you over there. This is an example. Once you start to turn this, the chain starts to move around here with the teeth right here on this.
Alright, so as you saw earlier, the clutch, as Chris showed, is connected to a chain that's going to turn the sprocket. Here we have 3 sprockets, each with a different radius, and what we're going to show is how the torque output from this will go into these and then ultimately change the amount of torque that then goes into the axle which this is connected to. So what's happening is you have the engine putting out a force onto this, which is then going to convert the torque to a different amount of torque that will then go back into the wheel.
Alright, so right here we have the torque 1, which represents the clutch right there. And we came up with some numbers that are just arbitrary. 175 newtons times the radius, or the lever arm. And that will make this value 2.6 newton meters. And then to find the total torque from the system when it's connected by a chain, we're going to use a ratio of the radiuses, and then we're going to take 2.6 newton meters times the radius 2 over radius 1 to find the total torque from the system of torque 1 and torque 2, which in this case with torque 1 and torque 2, which is this right there, if those are connected by a chain, is 13.9 newton meters. And then we came up with all the different situations right here for the different sized sprockets we're using.
So what we see eventually is that as the sprocket gets bigger on the side that the axle is on, the torque output on the axle is greater.